Hey, good morning, guys. For today's assignment, I'm just going to have you watch this video and take notes. I'll also submit the last problem that we do together. I'll kind of like speak to it a little bit, and then um, I'll post my answer so you can also fill that in your notes. And then tomorrow we'll do a practice problem as the assignment. So today's assignment is just to kind of make sure you understood what we began the other day, because now we're comparing two samples or two populations, and we're seeing if there's a difference in the proportions. Now, we can do that two ways. We can do it through a confidence interval, which I had you do on Monday, or today we're actually going to do it through significance testing. So a lot of this should be familiar because it's stuff we've done, but however, it's only stuff that we've actually did for one sample. And now we have two, and we're going to compare it to see if there's a difference. So in this first example here, it says, are teenagers going deaf? All right, so in a study of 3,000 randomly selected teenagers from 1988 to 1994, the data said that 15% showed hearing loss. However, in a similar study of 1,800 teenagers 20 years later, 19.5% showed some hearing loss. So what we're going to try to see is if our data has convincing enough evidence that the proportion of teens that have hearing loss has increased in the 20 years, okay? So like I said the other day, we got to define our proportions. We want to define what we make our first proportion and our second proportion. So that's what I did here in the beginning. You have P sub 1 and P sub 2. Now, our HO in this case, when we're doing this, is always going to be 0 because we think that if there wasn't a difference, the first proportion would be equal to the second proportion. There's two ways of writing it. You could write your HO like this, or if you solve for 0, just think you'd subtract this over and it would be written like this. The difference is 0. In other words, there is no difference. Well, we want to see if it's increased, meaning if P sub 2, if that's what we defined as those teenagers in 2005 and 2006, is greater than P sub 1. So I could write my HO like this and my HA like this, or I could write it as I included in the notes. You can always have 0 in there. Either one is accepted, okay? The conditions we should be okay with: random, 10%, large counts. Remember, large counts is your successes and failures. Now it's in each sample or group. They all have to be at least 10. Okay. So that was just kind of like the HO and the conditions. Now we're actually going to get into our significance testing. Okay. Again, you want to take the time to do this large counts condition because these numbers here you're going to need. All right, you're going to need them when we go to the calculator. So everything checks off here. It's random, it's 10%, large counts, all bigger than 10. All right. The next part in your notes you'll see is me doing this, but only if you do it by hand. Now, look, guys, I'm going to be honest. Some of us in the last quiz, I noticed doing it this way, okay? And that's great if you did. But I also saw some of us answering questions and including things in our answers that I didn't even ask in the question. So look, it's no secret that I'll get some of these questions out of a textbook or out of an online resource. And I do feel like some of us now are trying to look up those questions and answers. But mistakenly, what you did was you submitted the answer that you might have found online, and you answered part of the question that might have been online, but I didn't ask that on our quiz. So it was pretty obvious when we had those situations. Okay, a lot of us did it. And look, I'm asking you guys not to cheat. I'm allowing you to use your notes, use your videos, use our examples. I just don't want you working together. And don't go online and Google some question and find it and copy down what the computer tells you, because again, it was pretty obvious that you might have done something like that. All right. So in this case, again, ask me questions if you have any. We'll go over it. we'll make sure that you're well prepared going into our quiz when we eventually take it. But I don't want to see any more of that suspected cheating, right? Because look, a 0 is not worth it, right? Okay, back to this. Again, I show this just in case. The route that I would take would be the calculator. Now we're going to need these numbers up here for large counts. So it's going to be statistics, stat tests, all right? And we have 2 of them, right? So we have a 2-prop z-test. We have 2 proportions, and it'll be a z-test. So it's going to be whatever we designated as proportion 1, our successes. Well, that was the 450. Our sample size, that was 3,000. In sample 2, our successes, 351 out of 1,800. And what did we say our HA was? We said that it was greater than, right? That P sub 2 was greater than. Well, I should say the other way, I guess, less than. That P sub 1 is less than P sub 2. All right, so there's very similar numbers. There's our Z, there's our p-value, very close to what you would get by hand. Once we get that p-value, we know how to make a conclusion. Because the p-value is approximately 0, it's less than our significance level, we reject HO. And by us rejecting HO, we're saying that, you know what, we have evidence that there was in fact hearing loss, or that it did increase from the 20-year span. All right, going back up to question B. Between the 2 studies, Apple introduced an iPod or headphones now, and can we blame them for the increase in hearing loss? And the answer would be no. You know, even though that there is some association here between the 2, you can't say that one caused the other, right? So it's this whole idea about like correlation does not equal causation, something that we might have talked about chapters ago. All right, let's look at this next question here. In an effort to reduce healthcare costs, General Motors sponsored a study to help employees stop smoking. Half the subjects were randomly assigned to receive up to $750 for quitting smoking for a year, while the other half were simply just encouraged to stop smoking. Now, none of the 878 volunteers knew that there was a financial incentive when they signed up. At the end of the year, 15% of those in the financial rewards group actually quit. Only 5% in the other group did not or had quit. Do the results give us convincing evidence that a financial incentive might help people to quit smoking? So again, we have to set up our HO and our HA. You can write it like this, or if you choose so, you can set it up like P of F, which means financial incentive, equals the proportion of the traditional group, which means they didn't get it. All right. And then your HA would be that P sub F. All right. Do we have evidence that that there was an increase, or it helped people more so, a greater proportion? And P sub T. All right, again, you want to define what these are. It's important. All right, so you want to take the time to make sure you identify your parameters like I did there. You're going to check your conditions, pay special attention to the large counts, take the time to do that. You're going to need those numbers, all right, when we go to the calculator. All right, go back over here, look at the calculator. And again, same thing that we just hit. Menu, 6, 6. Not Z interval, right? Because we're not finding a confidence interval. We're doing a significance test. So it's going to be a 2-sample. Whoops, I'm in the wrong spot. Not confidence intervals. We got to go to significance test. So I'm sorry. It should be menu 6, 7, and then a 2-prop Z test. All right. So our first number of successes would be 66 out of 439 people. Then we have, in the second group, we have 22 successes out of 439 people. We've said that the first group, we're testing to see if it's greater than the second group. All right. Pay close attention when you see p-values like this. All right. Some of us miss that E sometimes to the -7. that just means it's really small. All right, that just means move that decimal place over 7 times. You're going to get a number that's basically 0. You don't have to write all those decimals out. Just tell me it's approximately 0. And just say, because the p-value is approximately 0, again, we reject, we have convincing evidence that these employees have a greater chance of quitting given a financial incentive. All right, so what we'll do, guys, is I just want you to try to take those notes, pay attention to what we went over today, and then this will be a practice problem that'll be an assignment tomorrow. So literally your notes today, your assignment for today is just to watch this video and make sure you're actively taking notes. And also try to organize yourself some questions so that if we, and let me know if you have questions, we can just set up a Zoom and there could be 2 of us on there, 3 of us on there, whatever. But I want to make sure you're getting this because this is now a section where we're not only doing confidence intervals, but also significance testing. So there is a little more going on, the fact that we're doing both, in addition to having not just 1 sample, but now 2, and we're trying to compare the difference. Okay? So guys, enjoy your day. Again, I hope that what I had said about the suspected cheating, I hope that kind of resonated a little bit. It's not worth it. I know you guys are in a tough spot right now. I know this virtual learning is not easy. Trust me, it's not easy to teach this way either. I wish things were different. But just look, I'm willing to give you the benefit of the doubt, and we're going to get through the rest of the year together here. Just let's not use those resources. Let's not try to put me in a position where we got to have tough conversations about somebody possibly cheating. All right. So guys, wish you the best. Weather looks great today. Take these notes, get outside, do something fun, and I'll talk to you soon.